In this lesson, we're going to talk about how to find the limit as your function approaches a vertical asymptote. So the first step in that is, of course, to find your vertical asymptotes, which you know in order to do that, you need to figure out where your denominator equals 0. And the difference between a vertical asymptote and a hole is that a hole is going to cancel and a vertical asymptote is not. So the first step, of course, is going to be to factor both the top and the bottom. So there you have it. Pause your video for a minute if you need to write down your factors, and you see that the x plus 4 cancels top and bottom, which means that's going to be a hole, and the only vertical asymptote that I'm looking for is what would make x minus 3 equal to 0, and that's going to be x equals 3. So the first part of the question, identify all the vertical asymptotes, that would be my answer, x equals 3. And the next part says evaluate the limit as x goes to 3 from the left side, from the negative side, of f of x. And if I had a graph, this would be pretty easy to do. So here's a really rough sketch of the graph, what it would look like. So we see that as we approach from the left side, we're going down to negative infinity on our graph. From the left side towards the asymptote, we go down to negative infinity. So if we had a graph, this would be really easy. We're looking at negative infinity for this one. And for number 3, I'm looking at as x goes to 3 from the positive side, it's going upward, which is going to be up to positive infinity. So if it had asked me for the limit as x goes to 3 in general of f of x, because I have one negative, one positive, this would be does not exist. Now this isn't actually asked for in this first question, but I am going to need to know how to do that for numbers 4 and 5. So if they don't match, this means that I have a does not exist or a D&E, which is a good, easy abbreviation. Now we want to know how to do this if I don't have a graph, so let's take a look at number 4. It says find the limit as x goes to 3 from the positive side of 1 minus x over x minus 3. So we see right away that 3 is going to be a vertical asymptote because nothing's going to help us cancel top and bottom. So the trick we're going to use is actually a trick we've been using is to plug in a number really close to this value of 3, and I need it to be from the positive side, so I need it to be a little bit bigger than 3. So I'm going to say this limit is approximately equal to, and I'm going to plug in 3.001. Number really close to 3 but not equal to 3 over 3.001 minus 3, and that would be 1 minus 3.001 is going to be 1.999 over 3.001 minus 3 is 0.001, so this is going to be a negative. Negative 1.999 is going to be a negative number divided by a really small positive number. So that's going to tell me I end up going to negative infinity. Negative over positive, negative, and it's going to give me a really big number because I'm dividing by a really small number. So this first one would just be negative infinity. Now they only asked me from the right-hand side, so I don't have to worry about the left-hand side. But if I look at the last one, example number 5, I want the general limit. In order to find the general limit, I'm going to have to do the right-hand limit and the left-hand limit one at a time. So you're going to have to write a little bit small here because there's not a ton of space, but I'm basically looking at the limit as x goes to 1 from the left-hand side, starting from the left-hand side. And again, whoops, before I do that, actually, I'm going to factor the bottom. What I get here is x minus 1 times x minus 1, which is the same thing as x minus 1 squared on the bottom. So I've got the limit on the left-hand side. I'm going to just call this f of x so I can write a little bit less. So I'm going to say of f of x, and then I'm thinking, okay, left-hand side, I need to plug in a number that's just a little bit smaller than 1. So let's say this is approximately equal to 0.999. So from the left-hand side, just a little smaller than 1, minus 3 over 0.999 minus 1 squared. So I've got 0.999 minus 3 is going to give me negative 2.001 divided by 0.999 minus 1 is negative 0.001 squared. And what I've got here is a negative number divided by a positive number, because a negative number squared is going to be positive. So negative divided by positive is still negative. So this is going to go to negative infinity. Then I'm going to do it all over again for the right-hand limit. So I've got x going to 1 from the right-hand side of f of x. And this time I need to plug in a number just slightly bigger than 1. So let's try 1.001 minus 3 over 1.001 minus 1 squared. And on the top, I've got now negative 1.999, and on the bottom, I've got a positive 0.001 squared. Since it's squared, it doesn't matter. I still have a negative divided by a positive is a negative. So my general limit then, thinking about my final answer now, as x goes to 1 of x minus 3 over x squared minus 2x plus 1 is going to be equal to negative infinity. Because both of these are the same, I do have a general limit is negative infinity. Remember, if they were different, like we saw in number 1, I would have a does not exist for the general limit. So that's it. Good luck with your homework and your mastery check.